Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. At every intersection of us and the digital world, you will find a recommendation system. We get recommended the products we would like to buy, or the songs we would like to hear, or the movies we would like to watch. These recommendation systems are omnipresent, and building these recommendation systems is one of the important topics in data science. Let's break it down. So, the entity the recommendations are shown to is the user, who is the consumer of the item, and the thing that gets recommended to the user is the item, like song, movie, or product. And these recommendation systems are built with two ways mainly. One, by using the already available observed interaction data, and second, by predicting the interaction data between the user and the item. So let's talk about already available observed data. So what do I mean by available observed data? So think of a table where the rows are users and the columns are items. And at every intersection of a user and an item, you will find some interaction value. So for example, if this was if the columns were songs and users were people, then you will probably find, let's say, a play count at the intersection of user and the songs. Now, obviously, not all users have interacted with all songs, so you might find some cells in this table empty, right? So, what I mean by building a recommendation system with available observed data is basically just looking at this existing data in front of us and building a recommendation system based on it. We don't necessarily know what individual users like, or we don't necessarily know the characteristics of items, like who is the artist of the song, which album the song belongs to. We only know the interaction between the user and an item, and we build the recommendation system based on that. So there are various ways to build a recommendation system based on the observed data. The first and the easiest way to build a recommendation system with observed data is by using an averaging method, which is also called rank based algorithm. What you mean by that is, we assume all users are same. We take the average of interactions for all items across all users, and then we figure out which is the most interacted item, and we recommend that item to users. So it's, think of, like, let's say a real life example would be, if there is a Marvel movie that gets released, and that becomes a box office success. So every single time, let's say if you open fandango.com or you find any movie related news, you will see that movie mentioned. That's because not necessarily you like the movie, but that's because that movie is extremely popular. It is interacted by so many people, watched by so many people, so it gets recommended to you. This method of recommendation is going to work every single time, because you will always find the most interacted items. The problem with this method is it is not personalized. The recommendations that you get may not be relevant to you. For example, if I don't like the Marvel movies at all, recommending a Marvel movie to me is not going to make any sense, because I'm not going to watch it. So that's the gist of rank-based algorithm or averaging method of recommendation systems. How can we mitigate this problem of increasing relevancy of recommendations? So what we could do then in that situation is we could, instead of assuming all users are same, we could make groups of similar users, and then on those groups we apply the rank based algorithm or the averaging algorithm. So again, think of it like, okay, these few users, we have some means of calculating based on the observed data that we can make clusters of users, and these clustering methods are topics for other episodes, but there are various clustering methods that you can use on this data to create clusters of users which are similar to each other, and then use the same averaging method that I talked about on those particular clusters. This will work great if you can create well-formed clusters. But usually what happens is clustering methods will suffer from the curse of high dimensionality of the data, which is topic for another episode. So then what you could do is you could not create clusters of similar users, but assume every single user as its own cluster, and then find users similar to that user. Then let's say user A is our input user, and user B is a person who has interacted with similar items as user A, and then we find the delta of interactions. Like for example, user B has interacted with some items that user A has not interacted with. We take those items from user B's list and recommend them to user A. This is kind of like word of mouth publicity. Like for example, one of my friends few days ago recommended me to watch Succession on HBO. I hadn't watched the series, but when I watched it, I was blown away and I liked it. So in this situation, the recommendation worked because the friend that recommended me Succession knew my tastes. He was a similar user as me. He was a similar watcher as me of the series, and he recommended something to me, and the recommendation worked. So you need to find some quantifiable method, some quantification for calculating the similarity between users. And then once you find similar users, then just finding the interaction delta between those two users, which items this user has interacted with that this user hasn't, and then recommend those items to that user. This third method, where each user is its own cluster, is called collaborative filtering or similarity based recommendation system. Now, averaging method, similarity based recommendation system, and clustering based recommendation system, all these three methods of creating recommendation systems depend on existing available observed data. If that data does not exist, you will not be able to create these recommendation systems. Now, there is another way of creating recommendation systems is by using this observed data, you can predict the interactions between users and items, and those methods are called singular value decomposition or matrix factorization or model based recommendation system or content based recommendation system. We will talk about those two methods in another episode. Thank you. Thanks for tuning in. I made this podcast to talk about intuitions behind data science, and we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.